Welcome, boys. This is a topic on machining and under AME 602, and the subject is speed layout of machine tools. In the last class, we discussed at length the speed range of a machine tool. Now we are going a further detail how the speed layout is being done in the gearbox for different kind of speeds. In this case, we have given a case study of a particular machine tool, and here the speed range from 110 RPM to 695 RPM. I have not specified which machine it belongs to, but the speed range in the gearbox is from 110 to 695 RPM, and the number of steps has been given as 9. And the series in the speeds are of equal intervals in different steps. This is in GP series. Normally there are 3 series: AP, GP and HP. Out of this has been found that GP series is the best among the all, because the speed losses is reduced here and the speed losses are uniform throughout the different ranges or different steps. And if it is a GP series, this one of the advantages, there is a common ratio here. The common ratio here is like this. This is 9 minus 1 is 8. So the last term divided by first term divided by root of 1/8. 8th root, which has been found out at 1.26. So this is the common ratio. If the first speed is 110, the second speed will be 110 into 1.26. It will become 139, round it up. It is rounded as 139. The third speed is 175, like this. The last speed is 695. You will keep on multiplying this. If it is AR, R is the phi is the common ratio, A phi square, A phi cube, A phi, like this. It keeps on. So fourth speed can be found out is A multiplied by phi cube. So these keep on adding it and representing this. So this is the speed range. Now we have to design a gearbox system. Now we have to attain the speeds and have to design a kinematic structure within the framework of the machine. And this is the layout, how these things are being done, how the speed things. This is the gearbox arrangement. And this is the speed layout, how the thing, and it has been found out that this can be achieved, the 9 speeds can be achieved through the 3 shafts, with the shafts are 2 stage. This is first shaft, second shaft, third shaft. So this is the first stage reduction, this is the second stage reduction. So 2-stage reduction, and we are achieving the 9 speeds. Mind that in all the cases when we do the gearbox arrangement, we have to have the cluster gear. The concept of cluster gear, that this is the sliding pair of gear. This is the casting, integrated casting. The gears are in compact. And this is the sliding. This is sliding. Normally this shaft is being splined. Splined shaft. Otherwise we cannot do the sliding. So this is a spline shaft. This portion is splined. Not this portion, because we have to range of sliding from this to this. The range of sliding this is, so there is no need for spline it for the entire shaft. So this is a spline shaft, so we can shift it from this to this. Gear changing. So this is a gear changing. And these 3 shafts, these 3 gears are normally in mesh with the 3 gears, one at a time. And these are fixed gear. This is fixed with the shaft. But this spline shaft, this is not a fixed one. This cluster gear is a sliding gear, and they are always integrated casting. So this, from this to this is the second shaft, from second shaft to this is third shaft. So this is the combination, 3 into 3, 9. So these are 9 subdivisions, and the number of gears you can find out. This is 3, 3, 6 and 6. So the 12 gears are there. And the number of sliding block, this is one sliding block, this is another side. The number of sliding block is 2. This is one cluster gear, is called one sliding block. And this is another sliding block. The total number of shafts is 3. So this is the driving shaft, this is the final shaft. And this is called the ray diagram. This is called the ray diagram. And this is spaced. This 9 equally spaced. First, second, third, fourth, fifth. So the first to third there's a 3 speeds. And from to this there's 3 speeds. From each there are 3 speeds. From each there are 3 speeds. One, this, third. So the gaps are this. The layouts are such that they're equally spaced. The speed is equally spaced. So this is how the gearing arrangement is done. So this is the beauty of this thing, that the cluster gear makes it the feasibility of this arrangement.
Mhm.